the one that actually absorbs the wavelength. So light hits rhodopsin. It converts rhodopsin into all-trans-retinol, OL, and opsin. Opsin can get recycled. It joins with 11-cis-retinol to make that. I don't know, that arrow's kind of confusing. It isn't in the book, but that's the idea, right? You have to take this plus this to make rhodopsin. So, the all-trans-retinol can be passed back along the membrane up here. You can also get all-trans-retinol from the bloodstream. So this is, I'll write it again up here. Because all-trans-retinol is our preferential, transport and use form. All-trans-retinol is what we want more than anything else. So we take in all-trans-retinol. We convert it to all-trans-retinil esters. That's the storage form. We're protecting it because with the OH on the end, it has the potential to do damage. So we esterify it so that we don't lose the active vitamin A, but also so that it doesn't cause problems for anything else. Then we can convert it to 11-cis-retinol, OL, meaning that instead of the all-trans, we have those two cis bonds, but we still have the OH at the end. Having the OH at the end is important because it means we can now store it in this other form. We can store it as 11-cis-retinil esters. When we are ready, either immediately after converting it or we can pull it out of storage, we make 11-cis-retinal. Al is the double bonded O at the end. We don't store it, we don't really directly go from retinal to retinil esters. It's a harder thing to do because when we make those esters, we talk about using water to go in and come out and going directly from an alcohol to an ester and then an alcohol to a double bonded O is much easier than going from a double bonded O to an ester. It just doesn't want to do that. I mean, it's, yeah. So, okay, this is a better form to store it in. So then, the 11-cis-retinal crosses the membrane when we're ready to recycle, or we need to make more rhodopsin, and we get 11-cis-retinal combining with opsin to make rhodopsin. When I say when it's ready, it means when those proteins have been upregulated, or when they've been freed up because they've lost their other substrate, right? Like that we're talking about, when I say when we're ready, cellularly something has signaled it to be ready. It's not just thinking, okay, I'm going to go grab this. It's a cellular process of signaling. It's a cellular process of having more proteins available. It's a cellular process of having those proteins let go of their cis-retinal so they're ready to take another cis-retinal. That's what I mean by ready. So the reason that I like this, again, is because you can see we're back in the land of esterification and when and where we store things and how we keep them from causing damage relative to when we need to use them.
Professor Thayer, should
Yes.
we expect this question to be drawn or to be in order?
Okay. So I will sometimes ask for drawing it either or. Like, in other words, you should be prepared to draw it. You should be prepared to understand a sequence. Like if I give you, I would tell you, because it's a circle. So I can say starting from rhodopsin or starting from all-trans-retinol entering this part of the membrane or this part of the eye. But I also am definitely going to talk to you about why you esterify. I want you to talk to me about when you're esterifying and why you're esterifying and what you can esterify. You can esterify things that you can make look like fatty acids, right? You can't esterify things that don't have any place to start. You wouldn't really esterify niacin. We're talking about fat-soluble vitamins and how to keep them. And the reason, going even one step back further, so fat-soluble vitamins are not water-soluble, which means we don't release them into the urine, and so we tend to build up toxicity over time. Part of the way that we do this is because we can esterify them. We are very good at storing them. And they're really important, which is probably why we've evolved an ability to retain them. But if you just start stacking up more and more and more vitamin A in the esterified form, and you're taking in more vitamin A, you just have a ton of vitamin A. Like it doesn't go out the same way that niacin would go.